Introduction. Embarking on the exploration of the Barents Sea, Norwegian oil company led by Equinor faced a complex mission to tap into the region's significant oil and gas reservoir while safeguarding its unique Arctic ecosystem, home to diverse marine life. The Barents Sea shallow depth, harsh Arctic conditions, and the looming threat of sea ice pose a formidable challenge to offshore drilling. This project report endeavors to address this challenge, emphasizing environmentally friendly, safe, and cost-effective plan development, covering essential aspects like drilling operations, formation evaluations, well completions and stimulations, and sustainable development goals. The report seeks to provide a comprehensive solutions with the backdrop of the Norwegian government's oil exploration proposals, Equinor ambition plans, and the pressing global climate crisis. This project becomes a critical exploration not only of a technical complexities but also of environmental responsibility in the Arctic realms.
Hello, my name is Naidatul Atika Johandi Mita Abdurrahman and my matrix number is BK2311024, and today I'm going to present about abstract. For abstract, drilling operations are essential to the petroleum sector because they include the construction of wells and resource extraction. The need of meticulous design and strict standards for maximizing effectiveness and safety is emphasized in this abstract. Technological developments in specialized equipment and systems like telemetry system and rotary rigs improve accuracy and lower operational risks. Efficient fluid flow and hydrocarbon recovery are the main priorities during crucial phases like well completion and stimulation, while hydraulic fracturing unlock hitherto untapped resources. Aligning with SDG, the sector is implementing eco-friendly methods and strengthening community partnership. To sum up, the drilling industry is developing with cutting-edge tools, cutting-edge technology, and environmentally friendly methods to make sure resource extraction complies with social and environmental obligations for a resilient future.
For drilling operation, the process of drilling oil underwater is much more complicated and harder than drilling on land. When compared to typical wells, offshore drilling presents a greater challenge for extraction, transportation, and environmental protection operations. Drilling in the Arctic is also more costly, complicated, and controversial than drilling on land. For design and specification, a semi-submersible drilling ship is used in harsh conditions. It can drill from 70 to 3000 meters, accommodating with its unique topography of the Barents Sea. This floating device sits low with a large part of its structure underwater, combined with a huge hang course, making it a very stable installation. In order to meet the difficulties of the Arctic drilling, this adaptation can include straightened structure to handle ice loads and improved heating systems to minimize the ice formations. For special equipment and technology use, horizontal drilling technique is suitable to be used in the region. It is because horizontal drilling are proved to increase the production rate of a well because it has a greater surface area and it allows access to oil miles away and in hard storage area. Some special equipment that can be used are icebreakers and ice-resistant platform. Icebreakers are vessels designed to navigate through ice-covered waters, breaking the ice to create a path for the ships. Ice-resistant platforms are constructed to minimize the risk of damage caused by collision of ice.
Now I will be presenting about formation evaluation. Formation evaluation involves in assessing the geology and characteristics of the subsurface formation to determine the feasibility of an oil extraction. I will be talking about three evaluation methods that can be used for oil plant development in ICC conditions, and those are sample and core analysis, seismic survey, and also well testing. So first of all is the sampling and core analysis. This method is considered essential in evaluating a formation as it offers crucial information that can be obtained from productivity testing or log readings. The core data includes capillary pressure, and this defines fluid distribution in the rock reservoir system, multi-phase fluid flow properties, and also directional flow fluid properties of the system. The data analysis is needed to design facilities that can handle unique properties of the extracted fluid and optimize the production strategies. It also helps in model creating that forecasts the reservoir's performance in the future and also assists in making well-informed decisions regarding production rates, extraction techniques, and also reservoir management. When conducting this method, the samples collected must be drawn directly from a reservoir in order to increase the succession rate of producing oil and natural gas from a reservoir. Now I will be presenting about formation evaluation. Formation evaluation involves in assessing the geology and characteristics of the subsurface formation to determine the feasibility of an oil extraction. I will be talking about 3 evaluation methods that can be used for oil plant development in ICC conditions, and those are sample and core analysis, seismic survey, and also well testing. So first of all is the sampling and core analysis. This method is considered essential in evaluating a formation as it offers crucial information that can be obtained from productivity testing or log readings. The core data includes capillary pressure, and this defines fluid distribution in the rock reservoir system, multi-phase fluid flow properties, and also directional flow fluid properties of the system. The data analysis is needed to design facilities that can handle unique properties of the extracted fluid and optimize the production strategies. It also helps in model creating that forecasts the reservoir's performance in the future and also assists in making well-informed decisions regarding production rates, extraction techniques, and also reservoir management. When conducting this method, the samples collected must be drawn directly from a reservoir in order to increase the succession rate of producing oil and natural gas from a reservoir. Next, I will be presenting about seismic survey. Seismic survey is also an essential tool in the oil and gas industry as it identifies prospect, assets, potential resources, reduce risks, and quantify reserves to drive a successful exploration effort. Seismic survey works by producing precise images of subsurface rock layers and can yield important data. The data obtained can be used to formulate an initial field development plan, which helps to lower the possibility of drilling in unproductive areas, maximize exploration costs, and minimizes the number of exploratory wells required, all of which can lower the total cost of exploration. Considering the environmental concerns, seismic survey helps reduce the environmental impact by preventing needless disruption to marine life and ecosystem by focusing on the exploration efforts on specific areas with a more potential resources. This helps to allay concerns about the state of land and also marine ecosystems in the environment. And lastly, I will be presenting about well testing. Well testing has been used to determine reservoir pressures, aerial extent, fluid properties, permeability, flow rates, production capacity, and many more. These tests are performed to evaluate the production potential and reservoir performance, whether the formation will produce or continue to produce, and to determine the limits of the reservoir, ensuring the most efficient methods of planning for producing wells and plants. The main function of the data from well testing is to construct reservoir models. Similar advantage to seismic survey, well testing data acts as a guide for well completion, production rates, and also facility designs. This ensures that the investment for oil plant development are directed towards the most productive, efficient, and economically viable area of the reservoir. It also assists in optimizing the reservoir management and designing production strategies, which helps to maximize the economic recovery of hydrocarbons. Now, considering the safety features of the plant, well test helps to understand the pressure dynamics of the reservoir. The understanding of pressure dynamics is vital for preventing reservoir damage and incidents such as blowouts or well control issues.
Hello, and I will proceed for the next presentation, which is well completion and stimulation. Basically, we need to know the definition of well completion and stimulation. Well completion is the process of an oil and gas well ready for production following drillings, and it is a primary goal of well completion to recover hydrocarbons in a reasonable and effective manner. The process of finishing a well involves several processes such as casing and cementing. The finding of the formation evaluation will be the only factor in determining whether to continue with the well completion for production or to abandon it. Next, for the well stimulation. Well stimulation basically defined as a treatment performed to restore or enhance the productivity of well stimulation of a well. Stimulation fall into two types, which is fracturing treatment and matrix treatment. Based on the case, the well completion should be done in a proper technique and activities to prevent such as permafrost problem from happening. Permafrost is mainly represented by rock with ice at the layer and strip. Well completion can be related to one of the process of finishing, which is casing. The suitable surface casing depth should be chosen to prevent the permafrost from happening. In order to reliably isolate the annular space, the casing shoe is recommended to be installed no less than 100 and 150 meters below the base of the permafrost. Next, there are also process of finishing, which is cementing. Cementing. A suitable composition of the cementing should be considered in order to finishing a well in IC based on the case. So next, for well stimulation, we need to choose the suitable treatment for the Barentsi circumstance. For example, hydraulic fracturing treatment. As basically, hydraulic fracturing treatment is a process that extract oil and gas from low permeability hydrocarbons bearing reservoir using high volume of chemical and water under extreme pressure. However, based on the case, the hydraulic fracturing treatment should require a specific modification. The selection of hydraulic fuel is essential to avoid freezing or gilling in cold weather and offshore equipment including pump and wellhead component. For the fracking process to be both safe and successful, temperature control technique including preheating fuel and ice management also must be used. So, however, in these well stimulations, the management and monitoring system should be continuously done for the safety to enhance the safety protocol in low temperature offshore operation to prevent from any accident to happen.
So, in order for industry to take part in search of oil and gas exploration, they must be in line with sustainable development goals in the world. So, the case study highlights the complex dynamics surrounding oil exploration in the Barents Sea, especially in the context of environment concern, climate change, and the need to sustainable development. In line with this consideration, a project on focus on oil exploration in the Barents Sea should address the sustainable development goals. So to sustain the development goals in the world, the industry must enforce an environment impact assessment or EIA. The industry must conduct a comprehensive EIA to evaluate the potential environment impact of oil exploration activity in the Barents Sea. They must also assess the risks associated with drilling, including the possibility of oil spill, and propose effective mitigation measurement. The goal is to minimize the harm to the unique ecosystem and ensure the sustainability of the region at all costs. So in case an oil spill in the water, a multi-layer response plan must be deployed depending on where the oil spill occurred and what the source is. So the regional and operator specific spill response plans and oil spill removal organization must work together in order to recover the oil spill. There are variety strategy that can operator can use in response to marine oil spill, including mechanical recovery, for example, booms and skimmers, chemical dispersion, and burning the oil off the surface of the water, in situ burning. So, other problems that may concern is the habitat. The industry must have a strong planning on conserving habitat in the Bering Sea. One way is by making a habitat mapping and research by conducting a comprehensive habitat mapping and scientific research to identify key areas uses by the animals in the habitat. So um, after that, the industry also must establish a marine protected areas for any animal habitat in this in for animal habitat. Industry can design it and establish it marine protected areas that encompass critical habitats for these species so that they can avoid on drilling on the site that have lots of animal that are protected. So another way to sustain development goals is by taking action on climate and greenhouse gas emissions. So the industry should proceed a climate action and greenhouse gas emissions. So they must address the concern raised by the Norwegian Supreme Court regarding potential greenhouse gas emission associated with oil production. So industry should develop strategy to minimize the carbon emission throughout the exploration, extraction and production phases. So industry can consider an alternative energy source and technology to reduce the overall carbon footprint. The best alternative is by using wind power. So wind resources is in the polar region are abundant and relatively constant due to the unique climatic condition. When the cold air masses collide with warmer air, it creates a powerful winds that blow consistently throughout the year. So, wind energy density, which is the measurement of available wind power per unit area, is exceptionally high in polar region. So, several studies estimate that the wind energy density in the area is almost 2 or 3 times higher than in more temperature region. The higher the energy density enables the generation of more electricity using fewer wind turbine. So by taking advantage of this abundant wind energy, we can contribute significantly to our renewable energy goals. So by applying renewable energy technology to the oil and gas industry, it brings reduction in energy costs and reduction greenhouse gases emission. So although we were reducing greenhouse gas emission, it remains a major problem for the oil and gas industry. The oil and gas industry needs to consider the efficient application of renewable energy technology to sites production conventional energy resources. So that's why we need to build a wind turbine to generate electricity.
Alright, for the next one, which is global climate crisis. This involves adopting comprehensive strategies to reduce greenhouse gas emission, carry out a carbon capture usage and storage or CCUS strategy, invest in CCUS technologies to capture and store carbon dioxide emission generated during oil and gas extraction and processing. Currently, CCUS operational facilities fitted with CCUS can capture around 90% of CO2 present in the flue gas. It is technology possible to achieve higher capture rates, and research is still ongoing to reduce the cost of doing so. CO2 can also be captured directly from the atmosphere by drawing in air using fans and passing it through an environment consisting of solid sorbents or liquid solvent. Evidence suggests there is more underground storage available globally than is actually needed to meet the need, and almost every high-emitting nation has already demonstrated having its own substantial storage resources. Thank you.
So my name is Jafni. So today I will sum up our presentation. So in conclusion, our journey into the complexities of all expression in barren seas reveals a delicate dance between unlocking valuable resources and safeguarding the Arctic ecosystem. We have explored the crucial role of advanced technology, specialized equipment, and sustainable practices in navigating the challenging conditions in this region. So from the design phase, where semi-submersible drilling ships prove essential to the utilization of innovative techniques like hydraulic fracturing and thermal cementing, every step underscores our commitment to responsible resource extraction. The focus on well completion and stimulation techniques further demonstrates our dedication to overcoming unique challenges such as permafrost and low temperatures. Importantly, in our project, it aligns with sustainable development goals, emphasizing eco-friendly practices, carbon emission reductions, and active community engagement. As we navigate the complexities of drilling in the Barents Sea, we prioritize a harmonious coexistence with the environment. This is not just about the extracting resources, it's about the sculpting a sustainable legacy amid the frozen expanse of the Arctic waters. We advocate for a balanced approach where technological innovation and environmental responsibility go hand in hand, contributing to be a resilient and responsible future for the barren seas. I think that's all from us. Thank you so much.